I'm recording it, we missed the first one. The first one is the easy assignment though, so let's not worry about that one. But that one, just so you know, you can make a date and a payroll, or you can you don't have to use the, actually, let me say something about this one. You can use, if you do the first one, you can use it inside of the second, especially if you have a hire date. Let's take a look at payroll for a second. I don't think there's a hire date in here. No, they're two independent classes. I don't see a hire date. I just see hourly rate and the number of hours. If you don't want to use integers for stuff, you don't have to use integers. You can use floats or doubles or anything you want. So you don't necessarily have to follow this exactly the way it is. But try to follow the requirements for the validation and stuff. So, alright, unfortunately I didn't record the first one, but let's try the second one. We'll see. Because some people might want to look back at this and go, what did you say about that? So, alright, so this is option number 2. If you don't want number 1, you say, hey, number 1 is too easy for me. I want like a challenge here. So I'm gonna do number 2. Number 2 is the day of year class. So assuming that there's a year that has 365 days in it, you're going to write a class named day of year that takes an integer representing a day of the year and translate it into a string consisting of the month followed by the day followed by the month, consisting of the month followed by day of the month. Excuse me. So, for example, day 2 would be January 2nd, and then day 32 would be February 1st. You just count the number of days. If you know how many months, how many days there are in a month, you should be able to calculate that out. So these exercises are really associated with months and days. All of them are actually, or just the first couple. So the constructor. So this second exercise is about constructor. So you say, hey, the first one was just like way too easy. I don't want to bother with that, or I don't want to create an array of objects. So if I don't want to create an array of objects, then let's take a look at number 2 here. Oh wow, now I got to create constructors. This one's all about constructors. So you have to create a constructor that should take parameters of integers. The day of the year and the class should be a member. Have a member function called print. And that prints out the day in the format month/day or month/day format. Test your class by inputting various different integers representing days and printing out their respective month/day format. So if I put in 365, I should get December 31st. So build the logic in any way you want. Part 2 to this one, and when you do this, you don't want to do all parts, by the way. Part 2, and this is a lot of work if you don't want to do the number 1, which is an array of objects, because that's why you don't want to do it. Maybe, who knows. This is a lot of work just to get around having to create an array of objects. But number 2 part of it says design the class name month, and then the class should have the following private data members. There's a month, and then there's a month number. Now we have a default constructor that sets the month number to 1 and the name to January. And then we have a constructor that accepts the name of the month as the argument, and then sets the name of the value passed as the argument, sets the month number to the correct one. So if I gave it 3, it'll say January, March. So we can have March in there. 2 would be February. So we have a name, this is a string that's associated with a number. So month. And then we have the appropriate setters and getter functions to name for the name and the month number. And then last requirement, oh, how about overloading the see in and see out operators? So the first one is an array of objects. The second one, the catch to this one, it's not so bad actually, but that see in and see out overloaded operators. If you're going to do this one, you're going to do the see in and see out overloaded operators. So most likely you're going to learn how to make an array of objects if you're going to do number 1 now instead. So let's see. Let's see what number 3 has in store for us, because that's the third option you can do of the first group. So the third option says, and hold on a second, let me bring it up in preview because it looks better. So you decided, you know what, overloading those operators is not for me. Then, and I can't figure out how to make an array of objects, and those objects just aren't working for me either. So I'm going to pick number 3. Number 3 It's got an employee and a production worker. If you took my Java course, this might look familiar. It's the same program that we had in Java, but it's written for C++. So that one, this one might appeal to those people who have taken the object-oriented programming in Java course. So let's see, you have an employee and you have a production worker. And you design a class called employee. This one is all about inheritance, by the way. So the class should keep the following information: employee's name, employee number, and hire date. And then you're going to write one or more constructors of the appropriate setters and getters for the class. And then next you're going to write a class named production worker. And production worker is derived from the employee class. So you're going to drive a class called production worker. And then you're going to add a shift and an hourly pay rate to it. So that array of objects is looking better actually at this point. So, and then the workday is divided into two shifts, night and day. So you have to assign a shift and a hourly pay rate for your employee, for your production worker. And then you're going to derive another class called the supervisor, shift supervisor. So the shift supervisor. In a factory, you have this thing called a shift supervisor, and it's a salaried employee who supervises the shift. So in addition to the salary, shift supervisor earns a yearly bonus with his or her shift meets production goals. So design the shift supervisor class that is derived from employee class that was created in part 1. So we got shift supervisor is at the same level as production worker. They both come from employee. So, and the third one is this team lead. Well, the team lead is also a production worker, so you have a team lead that's going to be built on top of production worker that's going to be built on top of employee. So if you read through this, there's some particular characteristics associated with that. You have a data member for the monthly bonus amount, required training. Make an abstraction of these. So the concept is, make a number that represents the number of hours of training that they've attended. Or, the monthly bonus and the rules associated with the monthly bonus. Everything belongs in the classes. The driver program that you're going to create can make one of each. Note that you can use the same driver program to test all parts of this implementation. You don't have to create separate driver programs. So if you don't like making arrays of objects or overloading operators, you can work with inheritance. So inheritance, might be your choice. Or you might decide, you know what, I'm going to make an array of those objects, which is probably the easiest thing to do of all three. So, but it's your choice. You may want to, So that was 1, 2, or 3. Pick one of those three. And it just says, well, what about number 4? Number 4 is in a category of its own. Number 4 is about abstract stuff. So let me talk about number 4 for a second. Number 4 will probably help you most in your programming career. But you don't have any choices on this one either. It's the only one of its kind. This one's called Pure Abstract Base Class. It might actually help you understand the concept of abstract classes. And this one will probably help you the most in preparation for the final exam as well. So this, you have no choice. If you want 5 points for this one, you just do this one. Nothing to choose from. The other one, you can choose your evil, whether or not you like overloaded operators, inheritance, or arrays of objects. That's your choice. So let's see. You're going to define a pure abstract class called base shape. And base shape can have the following members. It's going to have an area. Obviously, the area for a shape is what we're going to talk about in terms of the abstraction. So it's a double that can hold the shape's area. And then we have public member functions get area and calculate area. Now, it will tell you that this is a bad design. I can ask you, why do you think this is a bad design? Somebody will wait for 5 more minutes and nobody's going to answer me. But it's because you're creating stale data. You probably never want to store a variable for the area. You want to calculate the area, because what if the sides and the width change, or something changes about the shape? The area will be outdated. So if you want to fix the design, you can. and just calculate the area and not hold the area. So this way that this logic works is that you have a get area and calculate area. The calculate area is a function here that is going to set that value area. And then get area is just going to return the area. And this is the guy we're talking about that's going to be a pure virtual function. Because we don't want there to be a calculate area if there's a shape that has no sides or length or width or anything. So you make a abstract base class, and it becomes a pure abstract base class when you have a pure virtual method. You have a pure virtual method or function when it equals to 0. So go online, look it up, or go through the old lecture notes, and you'll see equals 0. I just gave everything away right there. But that's what we're working at here. If you want to make this just calculate the area, that's good. That's fine. And then if you're going to do that, you don't need a get area. The get area was just supposed to return this value, the area, which is going to be stale if anything changes. So you can do away with both of these two items and just create a calculate area virtual method and implement it. What's it going to do? It's going to take the data members of the class, depending upon the type of shape that you have, and calculate an area. So let's take a look at the shapes. So next, define a class called circle. And circle, it should be derived from the basic shape class. You want to call the basic shape class basic shape, you can do that. You can just call it shape if you want. It doesn't really matter what you call these things. It's just shape. And so it should have the following members. It has private data members. It has center X, center Y, center radius. Well, excuse me, radius. This is a word wrap, by the way. So this says center X is the long integer used to hold the X coordinate of the circle's center. And then it's a point. So we have the X and Y point of the center of the circle. So we have the long integer used to hold the Y coordinate of the circle's center. We got the circle, we got the center of the circle. And then we have the radius. And the radius is used to hold the circle's radius. And the radius here, so you can calculate the radius. Go on the internet, look it up. So, and then we have the public member functions here. We have the constructor that makes a new circle, accepts values for the x, y, and the radius. And you should call the overridden calculate area function described below. Well, let's take a look here. We have the get center x, get center y, and calculate area. So get center x returns x, get center y returns y. If you bring this up in Microsoft Word, it actually shows better without the word wrapping. This is from preview, so the word wrapping is a little funny. Or then we have the calculator. So you're going to override this method to implement it because it's virtual in the previous base class. You inherited it. Now you actually have to implement it. So you're going to calculate the area of the circle, and again, the area is going to be equal to pi 3.14, or however you want to represent it, times the radius, and then store the result in the inherited member area. If you don't have a base area, you don't have an inherited area either, which means you don't have to store it. You can just calculate it. So going back to that base class, that base shape, you don't have to give a stale area data member if you don't want to. Next, you're going to define a rectangle, and lo and behold, you're going to do something very similar to it. You're going to have a height and a width, and you're going to overload the calculate area, and then the overloaded calculated area is going to take the height and times it by so the area is equal to the length times the width. And then store the value again. If you don't have the area variable, you're not going to store it. You don't have to store it. You also want to make sure you do constructors in both the circle and the square. The constructor is going to accept the width and the length. Should call the overridden calculate area function if you're going to have a calculate area function to set a variable. You can do it in the constructor when you create the shape. So you have a get width and a get length and a calculate area. So after you've created these, you can create a driver program and create some circles and create some rectangles and see what their areas are. So the driver programs in all of these programs are extremely small. Not talking about a huge program, like a small itsy bitsy little main. You could stick the main in one of the derived classes if you wanted to. Just put a main function in there. And voila, you've got it written for you already. Questions on virtual? This is number 4. This one is in a class of its own. So you do this one, you get 5 points and add it to your score on the midterm, on the final exam. Excuse me. All right, lo and behold, now you got choices again. So you can do 5, 6, or 7. Let's see what we got here. Number 5. Or this is like, what do they call that? The Price is Right. You can have what's behind curtain number 5, number 6, number 7. Let's see. Number 5. Ooh, 5 is that dreaded copy constructor. Oh, ooh. So if you decide, the linked list part's not so bad, actually. It's the copy constructor. So, part 1, your own linked list. Design your own linked list class. There's millions of them on the internet. You can figure out how to create a linked list class. It's going to hold a set of integers. A million examples out there. You probably have one already. Actually, I made one in one of the assignments. Take your assignment, I think it's number 7 or number 5 or something like that. Take the one from your assignment number 5. And you've already done one. You probably have it on your computer, hopefully. Make sure that it holds an integer. So the class should have a, well, it has to be a class. I think it is a class, actually. I can't remember right now. It might be structure. Well, I could have nodes of structures inside of the linked list class. That works. Was there a class at all with that, or was it just structure? Well, turn the structure into a class. You know how to do that, right? Take the word structure and you replace it with the word class. Actually, it's the same data structure. It's the same. You can take a structure and turn it into a class just by changing the word struct to class. It turns into a class. Uses the same way, compiles the same way, runs the same way. Kind of weird how that works. The class should have a member function for appending, inserting, deleting nodes. Don't forget to add a deconstructor and destroys the list. Okay. Demonstrate the class with a driver program. Alright. So this one is probably the hardest of all of these options, but let's just toy with this for a second here. Part 2, we have a list print. Modify the linked list class you created in part 1 to add a print method. And that method is going to print out the nodes in the list. And then part number 3, this is the catcher right here. The list copy constructor. You want to be able to have a copy constructor created because you want to modify the linked list class in part 1 to add a copy constructor. Test your class by making a list and then making a copy of the list that displays the values in the copy. And then make a copy of it, change the values, and display both lists to see if both lists are the same list, or there's one was a copy of the other, or whether or not one actually has its own new values in it. See if you can see if your copy constructor works, essentially. Number 4 is a no-brainer. You just print it out in reverse order. You don't actually, why would you ever touch anything with the nodes that you created? You don't have to. Believe it or not, I've seen students take this list and reverse it, and they actually take and create all new pointers, they all do all these news, and they move the memory around, which is entertaining to look at because the memory right now is all over the place. It's your pointers that are making it into that list abstraction. So why would you move that stuff around to reverse it? But yeah, they copy it into different locations to reverse the order. You don't have to do any of that. Just take your pointers and reverse the order. Or better yet, make a doubly linked list and you got the reverse order. You get the forward and you get the back order with a doubly linked list. So yeah, don't move the list around. Just print it in reverse order. List reverse. And then list search. Look for an item in the list. So a modified list you created to include a member function named search that returns the position of a specific value in the linked list. Actually, you can just basically return a position number like search 5. Here 5. 5 is number 4 or something. You know, give me the value that's stored in 5. Or search for this value and tell me what node it's at or something. However you want to do it. It requires you to go through the list. So if you're really good with linked lists, you really understand that concept, this is probably going to be an easy assignment for you. So, member removal by position, so that you can take an item out of it. Give me take the 5th item out. Take the 6th item out. That's what you're doing with that. Make it work any way that you want to make it work. So, and then you can use the same driver program for all of these parts. I'd put them all together and create one little program. The biggest catcher here is going to be that list copy constructor. Copy constructor is going to be the challenge on this one. Any questions on the linked list one? You're going to have to use a class. I don't think you, unless you used a, well, you would have had to modify the assignment that you did, because the assignment that you did used a structure. It doesn't have a class. Doesn't have a structure either. Just has nodes, I think, doesn't it? Yeah. So now's your opportunity, if you wanted to create a linked list. Alright, so you say, okay, you know what, I don't like number 5. Let's move on to number 6. Right, number 5, that linked list, that looks like a lot of work. Let's take a look at number 6. You might like number 6. Number 6, if you took my object-oriented programming in Java course, you did this one too. You may have done this one, depending upon when you took it. This is a stack and a queue. So you've got this thing called an inventory. So you got an inventory bin stack. So, you don't like that. The linked list, you don't want to deal with the concept. You don't have to use linked lists in this. You can do this anyway. You can make an array-based stack, an array-based queue. But what you got? You're going to design this thing called an inventory class. And the inventory class is going to keep track of something. So, what do we get? It's an inventory class that stores the following members: a serial number, which is going to be just an integer value, a manufacturer's date, the member that holds the date of a part manufactured. You can use a string for that. Or if you did number 1, which was the date class, you can reuse your date class in this one. Reuse the date class, put it in here, you got a date. Change it around if you want. Or you can use a string, doesn't really matter. And then you got a lot number. That's another integer value holding the part lot number. So it's not a serial number, it's a lot number. Think of it like a manufacturer's ID number or something. So the class should have appropriate member functions for storing into and retrieving out of the data, setters and getters, by the way. Next, design a stack class that holds the class object described above. So you got a stack of objects. So you might be thinking, well, if I put it in an array, then I got to figure out how to put objects in an array. And I've already done assignment number 1. I have an array of people or payrolls or something. I can just use the same one. So this one actually goes along. If you wanted to, you could do number 1 and number 6, actually. Make your life easy. They both actually sort of work together. You have to have the same learning objectives on it. So you got the arrays of objects if you did number 1. So, alright, so you can create an array here. Or you can do a linked list if you wanted to. You can do a linked list with this. Or you can use any method that you want to get this into a stack or a queue. So last, design a program that uses a stack class. And the program should have a loop that asks the user if he or she wishes to add a part to the inventory or take a part from the inventory. And then the loop should repeat until the user is finished. So like an endless loop, you know, or a queue for quit kind of thing. If the user wishes to add a part to the inventory, the program should ask the user for the serial number, the date, and the manufacturer and lot number. Well, just ask for these 3 items up here. And then you're going to create an inventory item with the 3 items that you got from the user. So, if the user wishes to take a part from the inventory, the program should pop the topmost part from the stack and display the contents. I took this one off. I took that one off. Take something out of inventory. Put something into inventory. Excuse me. Just do the push and the pop. So you don't have to say take that particular item out of inventory. You don't have to do that. Just put an item on, take an item off. You don't have to be that elaborate with how you're doing it. So you got a basic stack. You don't like inventory items, put another item in there. Put stock in there. Or put something else in there if you don't like inventory. It's just basically an array or a linked list that's representing the stack. So the other part 2, make that stack into a queue. So a stack is a push it onto the top, pop it off the top. So a stack works with the topmost element. So number 1 goes in, number 2 goes in, number 3 goes in, number 4 goes in. Take one off. Oh, number 4 goes off. Put one on. Number 4 goes back in. So it goes off and on the same end. Queue, which, like, you know, I think I describe it normally as a plate of stack of plates in a cabinet. You never go for the one on the bottom. That's dangerous. You're going to break everything in the process. That's a queue. But if you did that at a bank, you'd get in trouble. If you kept working with the last person who came in was the first person who got served, the rest of the people will beat that person up in line. You know? So queues are different. Queues are the first person who comes in is the first person who gets served. The second person is the next person. Third person is the next person. So you come in one end and you go out the other end. So it's queue. So take it and modify it. How you want to do the terminology is fine. Just make a stack and a queue of your inventory items. You could use an array for it if you wanted to. Completely up to you. It does not have to be an efficient. So that was number 6. Lucky number 7, so you can do 5, you can do 6, or you can take what's behind door number 7. Door number 7's actually pretty easy. However, some people just don't like recursion. They hate it with a passion. If you can deal with the concept, this might actually help you understand recursion a little bit better. So you say, okay, I can deal with the virtual method. That's definitely on the exam. We actually have recursive questions on the final exam as well. So all this stuff will help you reinforce points that aren't going to be on the final. So let's take an example here. I don't want to do stacks and queues, and I don't want to do a linked list. Let's tackle recursion. So that might be your choice. If you do recursion, you're going to have part 1. You're going to have a recursive conversion. You're going to take the following function, and you're going to convert it to a recursive solution. This one's a loop. It's a while loop. So it's called sign, and while n is larger than 0, no parking, no parking, no parking, n minus minus. It's a loop. So turn that into a recursive method call instead. Part number 2, you can put them all, you can demonstrate all of these in one driver program as well. You don't have to use separate driver programs. Number 2. Is member function. So now you can actually use your C++ background to see. We got a member here. So write a recursive Boolean function named isMember, and the function should accept 2 arguments, an array and a value. Actually, you don't have to use objects with this. It can just be a value, any value. It doesn't. If it was an object, you could say instance of, but you don't have to do that. Or you can check to see if the object is of the same type. Don't even have to go that far. That's what I was originally thinking. Just an array and a value. And the array and the value could be the same data type, obviously. So the function should return true if the value is found in the array, or false if it's not in the array. And use a create a recursive function to check that, to see if it's a member of the array. So what are you going to do? And your recursive call is going to send the array back in. Or it doesn't really have to. Just increment the index values. +1, +1. Call me again, but move over 1. Call it again, move over 1. Call it again, move over 1. Until we're done. Part number 3 says string reverser. So write a recursive function that accepts a string object as its argument and prints it out in reverse order. That's a no-brainer. That one's pretty easy. Demonstrated with a driver program. Or part number 4, and part number 4. You have to do all 4 parts, by the way. You have to do all parts of all of them if you want full credit on all of them. If, for example, you look at this one and you say, I don't want to do this last one here, it's a recursive array sum, but I like all the other ones. Well, what do I got? 1, 2, 3, 4 parts. The whole thing's worth 5 points. I look at this and I go, oh, they didn't do the last one. Well, they only needed 3 or 4 more points. Here, I'll give them 4 points. Yeah. I'll probably reduce you by a point if you miss one part. But you'll probably get most of the points. These are just bonus points anyway. So I'm trying to help you. So these are just bonus points. So recursive array sum. If I want to do this one, I can write a function that accepts an array of integers and a number and indicates the number of elements as arguments. So the function should recursively calculate the sum of all of the members in the array. Adds up everything in the array. Demonstrate the function in a driver program. I would write, if I were doing this one, I'd put all these in one driver program. So and that's your last choice. So you don't even like this. This one's actually not bad, actually. It's just a little tricky. This one, if I were doing this, I'd do like maybe 1, that was an easy one. 1, 4, and 7. Or 1, 4, and what was the linked list one? No. Linked list is too hard. Although the stacking the queue is pretty easy. If you find yourself bored, you can do stacking the queue. But this one's not bad. So, all right, so when are you going to work on it right now? How long are you going to work on it for the end of the day? If you have questions, I can come around and I can talk to you. We do have to wait for attendance, so we can't just leave. You actually have to stay in the room. I will tell you when it is okay to leave. That will happen after, of course, but not immediately after the attendance gets taken. If you have to use the restroom, you may use the restroom, come back, and if you leave the room for too long of a period of time, you might miss the attendance if you're not in the room when the attendance gets taken. There's nothing I can do for you. However, I can tell you that the attendance probably won't happen until about 4:30-ish. As long as we're quiet and we're not disturbing our neighbors, we can work in teams and together. In order to get your 15 points, in fact, I would just send me the emails and I'll put the stuff back on the board when I'm done with this again. But it must be sent in by the time we take the final tomorrow. So tomorrow the final exam is scheduled for 3 o'clock. In the morning, I'll have some minor lecture stuff for you. In the afternoon, you'll be able to study for the final. You'll have some study time for that. But in order for me to use these points, they have to be in. It has to be in by 3 o'clock tomorrow, which means you can work on it today. You can work on it tonight if you want. You can work on it tomorrow morning if you want, and then have it sent to me before the exam starts, and you're in good shape. If after we take the exam, I can't, there's nothing I can do. Actually, the term is over with already. So, I mean, it's like this class is like scheduled so late, it's ridiculous. So, questions? Oh, thought I heard a question. No, we were just talking already. Okay, we'll try to keep the volume down. If you do need help, come over. Just like call me and I'll come over and answer questions for you and stuff like that. Some people might need help understanding the questions or interpreting the instructions, perhaps. So, only do 3 of them. If you do more than 3, you don't get any extra credit. You can do more than 3 if you want. You can do 3 for you, 3 for your friends, 3 for your neighbors. Sell 3 of them. I don't know. Don't sell 3 of them. That's bad. I'm promoting a bad thing there. So, all right, I'm gonna stop this video before I get in trouble.